Our last section we're going to look at is 3.3, and this is on function notation. So when you see the word notation, notation is a way of writing something down. Okay, that's what notation means. So we're going to talk about another way to write something down that you've been writing all along. All right, so we know that linear functions can be written in a certain way. Okay, they can be written in a certain way. Does anybody remember the equation that you can use that represents a line? And it starts out y equals, yeah?
Y equals mx plus b.
Yeah, y equals mx plus b. Okay, so on your first, I think you guys have a blank on your guided notes. It says, we know that a linear function can be written in the form, then you have a blank line. You're just going to write in y equals mx plus b. And there's nothing wrong with using y equals mx plus b. That's perfectly fine. But there is another way you can write a function, and it's called function notation. So you have, if you guys have another blank on your guided notes, you can write in the word function notation. And then in the box, you're going to write what function notation looks like. This is function notation. The only thing different about it compared to writing y equals mx plus b is instead of writing the letter y, you write that symbol. And what that symbol means, when you write this, F stands for function. And it means I'm about to write a function down that uses the letter x. And then you write down what the function is. So it could be something like 3x plus 2. So what you're doing as somebody reads it left to right is you're just telling them right away that what I'm about to write down is a function. So you're giving them that piece of information. And I'm going to use the letter x in the formula. So before you, well, if I went like this, before you even see what's under the gray box, I already know that it's going to use the letter x because they're telling me right away. That's basically why we use that notation. Just tell somebody what the variable is going to be that's coming up. When you write it y equals, you don't know what the variable is going to be. I mean, it's usually x, but it doesn't have to be an x. Maybe if we were doing a problem about like the number of nights at a campground, like we did a couple days ago, maybe we would use the letter n. So we can use other letters besides just x. And as I said before, this letter right here is the name of your function. We call that one function f. This comes in handy when you want to write down multiple functions like on the same piece of paper. If I wrote multiple functions, y equals 3x plus 2, y equals negative 8x minus 4, and y equals 5x plus 6. Other than saying like first one, second one, third one, if I said to you, look at the one that starts with y, well, they all start with y. You don't really know which one I'm talking about. But instead, if I wrote it like this, f of x equals 3x plus 2, I'm giving a name to this first one. This letter is a name. I'm calling the first one f. And then I could pick a different name for the second one. Let's call it g. This is the name. This is just the letter that you're going to see used over here. Negative 8x minus 4. Let's do this last one. Let's give it another name. Let's call it h. Usually the names are single letters. So let's use h. Those all mean exactly the same thing. The only difference is now if I said to you, oh, look at formula G, you know exactly which one I'm talking about. That's G. Or if I said, look at formula F, you know which one I'm talking about. That's F. Or H. That's H. Okay, so this way of naming functions is handy when we have a lot of them. Then we know which one we're talking about. If we just use Y all the time like we're used to, it's kind of confusing which one we're talking about if we just say, look at the one with Y. Well, they all have Y. Okay. And the name that you use, that's not important. You can use F, G, H, K, L. It's just any letter. You can pick any letter that you want to use. F, I would say F is pretty common. That's the one we use most often as a name. So how do you pronounce that? You don't say F parenthesis X parenthesis. That's not how you say it. Okay? When you want to pronounce this, it's pronounced, say it was with an X in there like that, it's pronounced F of X. That's how you pronounce this. F of X. And then you could say equals 3x plus 2. So this is a function of whatever letter is right here. Again, X is pretty common, but we've definitely used other letters. I think we did a problem with DVPs. We might have used the letter D. I know we did the camping problem or vacation problem, and we used the letter N, so we've done that. But X is most common. So any questions on how to say that? F of X. So how would you pronounce this second box? Yep.
G of X.
G of X, yeah. Equals, and then you'd say negative 8x minus 4. It's G of X. How would you pronounce the last one? Here's that?
H of X equals 5x plus 6.
Right. H of X equals 5x plus 6. That's it. So all that we really did was change y to f of x. It's just a different way to write the letter y. So you guys should have a little kind of a short line where you can write that in. So all we did was change y to f of x. Okay, another question. I think we talked about this really, really early on. If I gave you something like f of x equals 2x minus 5, and I said evaluate for x equals 3, what does evaluate mean? What does evaluate mean? Yeah? Sorry, what did you say? I thought you were saying more. I wasn't sure. What did you say?
Was it maybe find out?
Oh, find out. Okay. So, like if it said to evaluate this problem when x is 3, what would you have to do here? Yep. Okay, so it says evaluate when x equals 3. So what are you going to do with the 3?
You're going to fill in all the 3 for all the x's.
Yeah. You're going to take the 3, you're going to fill it in for the x, and then you're going to tell me what you get is the answer. That's what evaluate means. Well, if we use this new notation, I could still write evaluate for x equals 3, or I could just write this. If I put f of, now it's not an x anymore, it's a 3, f of 3, that means to take the 3 and fill it in for x and tell me the answer. This is exactly the same as writing out this sentence. This means evaluate the function f at the number 3. If I wrote, let's say I wrote this, g of 2. The first letter tells you which formula you should be using. Which formula does this one say to use? Oh, Sophie? Which formula are we supposed to be using in this one? Right, we're using formula G. And what number are they telling me to plug in to formula G? Yeah? 2. Oh, plugging in 2. So this is the formula you're supposed to use. This is the number that you're supposed to plug in. So this means evaluate formula G when the x value is 2. That's what that notation means. So evaluate means to plug in a number for the variable. And this is a shorter way of telling you to do that. So look at the letter they give you, then find that formula. Once you find the formula that starts with that letter, take the number they give you and fill that number in for x. So like in this case, it would be 2 times 3 minus 5, and then you tell me what that answer is. Any questions on that? So let's look at example 1. So it says evaluate, and they're only giving me one formula, just formula F. There's no G, there's no H, it's just one formula. And how many different numbers do they want me to plug in to evaluate here? About Abby? 3. So it's 3 separate problems. They have nothing to do with each other. They're just 3 separate problems we're going to do. So to evaluate this function at those 3 numbers, and then put your answers right here. So what's the first number that they want me to plug in to that formula? Natalie? What's the first number they want me to plug into that formula?
-3.
-3. So we're going to do 4, change the x to -3, and add 7. Okay, Joe, what's 4 times -3?
4 times -3. -7. Oh, wait.
Yep.
-12.
-12. Yep. So -12 plus 7. Yep. What's that? Oh, the 4 is a negative. Thank you. So now it's a negative times a negative, which will make that a positive. Yes, that's important. So it's -4 times -3, so that's positive 12. And now, what is 12 plus 7? How about Maya?
Oh, sorry. I had like a moment where I forgot for a second.
That's okay.
19.
19. That's the answer. So f of -3 equals 19. That's the answer when you plug -3 in. Now let's do 0. -4 times 0 plus 7. So again, this would be pronounced f of 0. What is the answer when you plug in 0? How about Abby? What do we get for that one? What's -4 times 0? Plus 7?
Oh,
7, yeah. So that one comes out to 7. Yep. Yeah. And how about f of 2? Finnegan, how would I write that one?
It would be -4 of 2.
-4 times 2, yep,
Plus 7.
plus 7. It's not always plus 7. This formula is a plus 7, but it could be a plus 6, could be -3. Every formula is a little different. Okay, -4 times 2 is -8. And what's -8 plus 7, Lexi? -1. So even though it looks a little different, like this notation that we're using to write it down, it's not anything new you haven't done. Taking a number, filling it in for a letter, and then doing the arithmetic. Something we've definitely done before. Any question on that one? So there's a lot. This is why I had to staple it together. I probably left way too much space to do example 1. You didn't need that much space. Okay, this is just a reminder. This isn't something you have to put on your record sheet, on your guided note sheet. What's the word that we use to remember how to solve equations? Not PEMDAS. That's how we simplify when we do arithmetic. This is the word we use to solve equations. Yep. SAM. So remember, S is simplify. And what are the two things that can always happen under simplify? Yep. Yep.
Distributive property.
Distributive property. Yep. That's always the first one. We actually saw that in the test question we just went over. And what's the other thing you might have to do under simplify? Yep. Combine like terms. CLT. Combine like terms. So we said SAM. What does the A stand for? Well, it could be two things. It could be this or this. Yep.
Addition or subtraction.
Addition or subtraction. And then the last thing you do when you're solving an equation could be this or something else. Yep. Multiplication or division. Okay, so just a reminder about those steps in case they come up when we're doing an example. All right. So this one is example 2. It's at the bottom of your front page of your guided notes. And it's a little different than example 1. Example 1, they gave you a number for x and said to fill it in there. This time, they're going to give you something for this number, and you're going to fill it in here. So we're going to be filling in a number, but it's not going to be on the side with the x. It's going to be on the side with the f of x. So it's the other side. So it says, find the value of x so that the function has the given value. So look at the difference in what they give you. In that red box, does it say x equals 4? Yep.
N of x equals 4.
It says n of x equals 4. It does not say x is 4. If it said x equals 4, then I would just change that to 4. But it says n of x equals 4. Where is n of x in that equation? Which side is it on? Yep.
It's on the left.
It's on the left. They're telling me that that should be replaced with the number 4. They're telling me n of x should be turned into a 4. So take what they give me, change the n of x to a 4 on the left, and the right stays exactly the same. This is why I mentioned the SAM, because when you do this one, now you have to get x by itself. Okay, so little bit different than example 1. It's almost like it's the opposite. So, Cadence, what would be my first step to get x by itself there? Yep, you'd subtract 2 from both sides. And if I do that, what would it give me? 2 equals 2x. Good. So we did adding and subtracting. How about my last step? Yep.
5 by 2.
Good. Divide by 2. Divide by 2. And what do you get for x? 8, 1. Very good. Okay, so this problem was backwards from example 1. They gave you the value on the left, and you figured out the x value. In example 1, they gave you the value on the right, and you plugged it in, and you found the one on the left. So it's just be careful when they give you a problem. Just pay attention to what they say it equals. If it's x equals, you fill it in on the right. If it's f of x equals or n of x equals, that's usually on the left. All right, so this is something we did, I think we did it yesterday. We talked about how to graph a line. And how many points did I say we should do when you want to draw a line? At least how many? Yeah?
At least 3.
Should do at least 3. Because if you only do 2, you wouldn't know if you made a mistake. Any 2 points are always going to be in a straight line. But if you do a third one, and it looks like that, then that means you probably did it right. But if you did a third point and it was up here, well, now we know something's wrong. Because if you're drawing a line and they look like that, that's not a line. So we'll do at least 3. Sometimes we even do 4 or 5. We generally don't do more than that. Now, when you are drawing a line, you get to pick the points you want to use. Because we've talked about lines, and imagine putting points on it. How many points are on that line? Yeah? Infinitely many. Well, we can't do infinitely many. We don't need that many. If you do 5 of them, and you space them out a little bit, that's usually pretty good. So what we want to do is pick points, about 5 of them, and we want to space them out. And my suggestion to you would be to use those as your x values. Do you have to use these? No, you don't. There's infinitely many points on this line. You could let x equal 6. You could let x equal 12. You can use anything you want. The problem is, if you start to use numbers that are too big, usually it doesn't fit on your graph paper. So we want to try to pick numbers that are small, easy to work with, and don't go off our graph paper. So this is kind of a template of what your table is going to look like when you do a problem. And you guys already have that table with the numbers? Okay. There's nothing to fill in on this one because we don't have a formula. Like, if if I did go back to the last one, f of x equals negative 4x plus 7. If I wanted to actually draw that, I would write that in right here. I'm not gonna, but f of x equals negative 4x plus 7. And this table is kind of like the one we did, I think it was in the warm-up yesterday. You got a column for your x's, you got a column for your formula, then you have a column for your f of x, and then you have your coordinate. What letter did we used to use in that column? That was the third one, yeah? We used to use y. It's the same thing. We're just calling f of x y, or we're just calling y f of x. But it's exactly the same thing. So, once you have your table, plug in each one of these numbers into the formula that's going to be at the top of box 2. So you'll have a formula there. You're going to plug all those numbers in. In the third column, you're going to write out the answers. So the second column, you're going to show me the calculation. The third column, you're going to do the calculation. And the fourth column is just the number in column 1, comma, the number in column 3. And that gives you a coordinate. So just like when we did domain and range and we found coordinates. And then the last step is just to graph your points and draw your line. Okay, so what I did for you guys on the guided notes is I already put the table on there, so you have a blank table we're going to use for example 3. You've already got a piece of graph paper printed right on your guided notes. And I think I did the same thing in the homework. This graph paper already printed on there for you to use. Yep.
There's only graphic at the bottom.
Yeah, this one is just a sample to show you how it would work. There's nothing we're actually going to do with this first table. This is just a blank copy of the table. In the next one, I'm going to give you a formula to put right here, and then we'll actually do it. Yes. Yep. Does everybody have this table? No? Or I'm sorry, just these last two things. So you got 2 blank lines that say next, comma, and then lastly, comma. And just write the part that's bold. And I think this is the second to last example. Okay. If you have something that's straight when you draw a line, that's helpful. So if you have like your ID, once you put your points, you can use your ID to draw a straight line or something straight. All right, so this one says to graph. I'm just gonna fix that. I don't think you guys already have the equation written, so you want to write this down. Y equals 1/2 x plus 5. Okay, what are the 5 x values that I suggested you use? You don't have to use them. If you want to pick other ones, go ahead. But these are the smallest ones, so they're the easiest ones, yeah? Two. Okay, so there's our x values that we're going to plug in. What's the formula that we're going to plug them into? What did they tell me the formula was? Yep. Cheers. 1/2 x plus 5. So I'm going to write it out right now, filling them all in. So you're going to write this formula 5 times. Each time, you're going to change the x to the number you're filling in. Okay, so the first one is 1/2. You know what? I'm just going to write them all like this right now. So there's all my formulas. Now just fill in the number that you're changing it to each time. -2, -1, 0, 1, and 2. You don't have to do the calculation out in column 2. That's what column 3 is for. And at this step, I would just use your calculator to get all the answers. So the first one is 1/2. What's 1/2 the same as a decimal? Yep. 0.5, right? It's 0.5. So I could just do 0.5 because that's easier for me to do on the calculator. And if I put 1 divided by 2, it's just going to change it to 0.5 anyway. So I'm just going to do 0.5 times -2. And then I have to add 5. So I got 4. That's the first one. Now do the next one. 0.5 times -1 plus 5. 0.5 times -1 plus 5. It gives me 4.5. Okay, the next one I think we could do 1/2 times 0. What's 1/2 times 0? Yep, Lexi? Plus 5? 5. Now, remember what we said about linear functions. When you look at the x column and when you look at the y column, you should see a pattern of adding the same thing over and over. Well, I definitely see that in the x's. Plus 1, plus 1, plus 1, plus 1. Does anybody see what the pattern is in the y's? If you see it, we don't have to keep doing these out. We can just fill them in. Yeah? You're adding 0.5 every time. So what would this next one be? 5.5. And the last one? Yep. 6. It has to follow a pattern. And the fact that it follows a pattern, that kind of shows us we did it right. If it didn't follow a pattern, then something's wrong. All right. Now, just take each one of those and write them as a coordinate. The x value is the number in the first column, and the y value, or the f of x value, is the number in the third column. So there's all my x's. And Mia, what's my y value, or my f of x value for the first coordinate? 4. Sean, what's my y value, or f of x value for the second coordinate? 4.5. And then 5, 5.5, and 6. Okay, when you're graphing, it's a little annoying when you have a decimal, but I'm going to try not to give you a decimal that's anything worse than a 0.5. Okay, you're not going to have like a 0.7 or something like that. All right, so let's graph. Anaya, how do I graph the point -2, 4?
We'll put -2 on the right side.
So we're going to go left 2, yep. And then
Up 4.
up 4. Good. There you go. So there's your first one. And hopefully all the other ones line up nice and straight. Brady, how do I graph the second point?
4. I don't know. Over to the left one.
Okay, left one. Yep.
Up 4.5.
1, 2, 3. Let's see. 1, 2, 3, 4.5. Okay, there's that one. Natalie, how do I do the third point?
Just go up 5.
Just go up 5. Yep. So there's that one. And Emily, my sixth point.
To the right, to the opposite.
Okay, I think I skipped one. Right, 2, 1, 2, 3, 4, 5, 6. And Joe, how do I do the point that's in this row? Because I missed that one.
One.
Yeah.
You go over 1.
Which way?
Left.
Left would be if it was a negative.
Right.
So right 1, yep.
And up 5.5.
Up 5.5. Yep, perfect. Okay. All right, so there's our points. And remember, when we're drawing a line in this section, we should connect them. So just going to kind of estimate it. And about like that. Again, my suggestion is if you have, your ID or something, you could use that. And we put an arrow on each end to indicate that it keeps going. And that's how you graph a line. Any questions on that one before we do the last one? Yes.
So our last year's teacher, she was like this. Put like this, like graph it, and then put the little do thingies.
The things.
Like the coordinates, you make us put the coordinates right next to the dom.
Oh, next to it. You don't have to label the coordinates on the grid. Especially, it might start to get kind of squished together. Depending, like these points are all really close. So if I was going to try to write coordinates for all these, I would have to, I'd have to put them pretty small. But as long as, if you've got the table, that's why I have the table separate. So that way you've got plenty of room to write them down and plenty of room to do the graph without it all squished together. Yeah, so that's okay. All right, last one. Let me see if I can make that fill the page. There we go. All right, so before we even read the whole thing, what's the name that they're giving to this formula? Yep, Natalie?
I don't know, but anyways,
Yeah. What's the name they're giving to this formula? Yeah, Natalie? C of x. H of x, C of x, G of x, H of x. You see all different letters. C is the name of this formula, and they probably use C because something in the word problem probably begins with a C. Yep. Yeah, apparently this problem is about the cost of something, so that's why they chose to use C. So it says that that formula represents the cost in dollars of buying X tickets to a concert, and you have a coupon for $10 off. So if you look at the formula, where is the $10 off your price represented in that formula? Yeah? That's the minus 10. That's the $10 off. And if you look at the formula, it kind of tells you how much each ticket is to go to the concert. How much does it look like each ticket is? Caleb?
$17.50.
It's $17.50. So if you buy one ticket, you pay $17.50 and you get $10 off. If you buy 4 tickets, well, it's $17.50 a ticket times 4 tickets, but you still get $10 off. You don't get $10 off every ticket. You just get $10 off total. Doesn't matter how many tickets you buy. Okay, what is the total cost when you buy 5 tickets? So they're giving us a number, but we have to figure out where the number goes. There's 2 spots it could go. It's either going to get plugged in for the X, or it's going to get plugged in for the C of X. We've done both. Does anybody have a thought where the 5 would get plugged in for? Well, let's start with what the 5 is. What does 5 represent? It's the
Amount of tickets needed.
the amount of tickets. So what in that formula represents tickets? C of X or X? Yep.
X.
X. X is tickets. C of X is the cost of the tickets, not the tickets. So we're going to plug 5 in. Right there. So we're going to find the cost of 5 tickets. That's C of 5. All right, so Sean, could you tell me what I would write down here, and then I'll type that into the calculator to find the cost for 5 tickets.
17.5 times 5.
Yep.
times 10.
Perfect. 17.5 times 5. So that's the cost, and then we get a $10 discount, so we minus 10. There you go. So it's 77.5. When you write money, it's a little weird to write it like this. You don't really see a price that's 77.5. Usually we put the cents as a 2 decimal. So that's how you'd want to write the cost in this one. 77.50. All right, so now part B. It's a little different. They're asking how many tickets can you buy with $130? So they're giving me a number. What does that 130 represent? Is that tickets, or is that a cost of tickets? Yeah, that's a cost this time. Since it's a cost, where is it going to go in that formula? For the X or for the C of X? Which one gets replaced? Lexi? The C of X. So this time, don't do anything on the right side. Just leave that the same. But the 130 is your cost. That's going to get filled in right where I circled. When you're filling in on the left, this is now like a SAM problem. You have to solve for the variable. Okay, what would be my my first step? I'll give you a hint. There is no S part of this problem. There's no distributive. There's no combined like terms. So you can jump to adding or subtracting. Yep.
Subtract 10 from both sides. I mean, add 10 from both
Yep. We're going to add 10 on both sides. Can you tell me what that would give me when I do that?
sides.
140. Anything else?
Equals 17.5x.
Good. Equals 17.5x. And what about my last step? 80? Good. Divide both sides by 17.5. Now, I'm going to need my calculator to do that. I don't know what that's going to come out to. Do you already know? Oh, you know that. Okay. All right. So I don't know what it comes out to yet, but I have to think about it for a second. What if it comes out to like 5.2? If it came out to 5.2, how many tickets would I be able to afford? Can I buy 5.2 tickets? I would only be able to buy 5, right? If I can afford 5 and a little bit more, but I don't have enough money to buy a full 6 ticket, well, I can't buy half a ticket. So I need to divide that out and see what happens. Maybe it'll come out even. I don't know. Maybe it just comes out nice. But we got 140 divided by 17.5. All right, so this time it did come out exactly to a nice number, and I can afford 8 tickets, and I will have no money left. I'm going to spend every dollar I have if I buy 8 tickets. And we should label that tickets. Yes?
For the problem, it says 130, you put 140.
So we added the 10.
Oh, yeah.
It's our first step. So we had 130 and then added 10. Okay. Same idea, like if you were painting a room and it said you need like 2.4 cans of paint. If the paint only comes in one size can, well, you're gonna have to buy 3, and you're gonna have some left over. Right? So sometimes you have to round your answer like that. All right. So homework is the worksheet. It's on 3.3. That's going to go on term 2. Okay, so term 1 grades are all done. This worksheet is due. Let's see. November 7th. That's the next time we have class.